So, we're agreed then that our rocket is travelling at point 8c. So let's consider the situation where we have a series of events that we want to discuss in terms of the special relativity. So the rocket leaves the Earth, and let's say that that's event number 1. It then travels all the way to TRAPPIST-1, 40 light years away, and when it arrives there, event 2 is recorded. Then it turns around and returns to the Earth, where we record the final event, event number 3. So the question then is, what happens to the crew on that ship, and what happens to them relative to the people they leave behind on the Earth? And of course what we're doing now is we're introducing the very famous twin paradox. Because clearly, if, as Michael said at the beginning of the lecture, if the rocket is stationary and to the people on the rocket, then it's the Earth that's moving. And likewise, to the people on the Earth, it's the rocket that's moving. How can both sets age more slowly? This sort of conundrum, where we have two conflicting or apparently conflicting answers, is known as a paradox. And there are often things that we encounter in physics that we then have to think even more carefully and more deeply about in order to solve. Now, to solve this problem, I'm going to need to have some twins for this problem, or perhaps some clones. In other words, duplicates of the people on the rocket and the people back on Earth. So, the rocket leaves, and the question is, who is older, and by how much?